Evaluate the function f of x equals x squared minus 3x all over x squared minus x minus 6 at the following numbers and use your calculations to guess the value of the limit of f of x as x approaches 3. For a problem like this, when we want to make some tables of values to get an idea of what's happening near our x value for the limit, it's nice to make two different tables of values. One for the values that are smaller than the limit we're looking at. So 2.5, 2.9, 2.99, and 2.999. And then one for the values that are larger than we're looking at. So this will be 3.5, 3.1, 3.01, and 3.001. And it's nice to have the values getting closer to your limit number, in this case 3, so that you can read down the tables of values and physically see what's happening to the numbers as the x value gets closer and closer to the number that we're looking at. So for each of these, truly I recommend using a calculator. If we want to evaluate f of 2.5, for example, that's going to be 2.5 squared minus 3 times 2.5 all over 2.5 squared minus 2.5 minus 6. And you could try and work all of that out by hand, and then you'd end up with an awful division in the end. Or you can just pop it all into a lovely calculator and get your approximation of 0.555555. And as I said, that's actually an approximate value, so I'm going to erase that equals sign and change it with an approximately equal to sign. So our function value there is going to be about 0.555555. And I'm not going to write out all of the other calculations because truly all you need to do is plug those into a calculator. For 2.9, we get 0.591837. For 2.99, we get 0.599198. And then for the next one, we get 0.59992. So it looks like we're getting closer and closer to a nice round number there. If we look on the other side, the values that are larger than 3, our function values are going to be 0.636364, and then 0.607843. Please take your time and calculate at least a few of these. Maybe not all of them, but at least some, because you really want to get practice using your calculator for calculations like this. It's very easy to make a mistake somewhere, especially with subtractions and negatives and decimals. And so you really want to make sure that you're absolutely proficient at using your calculator so that if you need to use it on a test or in the future to do real-life calculations, you are unlikely to make a mistake. Let's see, we've got one more here, 0.60008. And what we can see here, hopefully, is on both sides, we are getting numbers that are getting closer and closer to 0.6. So our guess is that the limit as x approaches 3 of this particular function is going to end up being 0.6. Definitely looks like it.